Let x sub 1, x sub 2, x sub 3, ... be a sequence of random variables converging almost surely to another random variable x. If 0 is less than or equal to x sub 1, which is less than or equal to x sub 2, which is less than or equal to x sub 3, which is less than or equal to ... almost surely. Then the limit as n approaches infinity of the expectation of x sub n is equal to the expectation of x. Let f sub 1, f sub 2, f sub 3, ... be a sequence of Borel measurable functions on the real numbers, converging almost everywhere to a function f. If 0 is less than or equal to f sub 1, which is less than or equal to f sub 2, which is less than or equal to f sub 3, which is less than or equal to ... almost everywhere. Then the limit as n approaches infinity of the integral from negative infinity to positive infinity of f sub n of x dx is equal to the integral from negative infinity to positive infinity of f of x dx. Analysis: the monotone convergence theorem, integral form. 1. Mathematical deconstruction. The image presents a corollary to the monotone convergence theorem, MCT, applied to functions rather than random variables. This is a foundational pillar of Lebesgue integration, governing when it is mathematically safe to swap a limit with an integral. The object, a sequence of functions fn of x defined on the real line R. Condition 1. Regularity. The functions are Borel measurable, ensuring they are compatible with probability and integration frameworks. Condition 2. Non-negativity. 0 is less than or equal to f1. The functions never act as det. They represent positive values, for example volume, price, or probability density. Condition 3. Monotonicity. f1 is less than f2 is less than f3. The sequence is non-decreasing. At every step n plus 1, the function value is equal to or greater than it was at step n. Value is strictly accumulated or maintained, never destroyed. The result. This equality asserts that the limit of the integrals, the trend of the values, is identical to the integral of the limit, the value of the final trend. Two. Intuitive logic. In standard calculus, taking a limit inside an integral is dangerous. A sequence of functions can become infinitely thin and tall, causing the area to vanish or explode in the limit, creating a discrepancy between the approximated total and the actual total. The MCT provides a guarantee. If a system grows by strictly adding non-negative value, never subtracting, the final total is exactly the sum of its accumulated parts. There is no leakage of value at infinity. 3. Financial alpha analogy. The irrevocable revenue protocol. To internalize this, visualize the valuation of a scalably expanding tech platform. X represents the universe of potential users. Fn of X represents the revenue generated from user X given the platform's feature set at version n. The monotone condition. The platform operates on an irrevocable upgrade philosophy. Every update adds features, Crucially, an update never removes a feature. Version 1 monetizes only US users. Version 2 monetizes US plus EU users. Revenue is greater than or equal to version 1. Version 3 monetizes global users. Because revenue is strictly additive, the sequence is monotonically increasing. The integral, the total valuation of the company at version n. An investor wants to know the valuation of the company in its final, perfected state. Method A. You calculate valuation at version 1, 2, 3 and track the trend. Method B. You look at the ultimate feature set and value that single product. The monotone convergence theorem guarantees that method A and method B yield the exact same dollar figure. If the upgrades were not monotone, for example version 4 alienated users, this guarantee would fail. The projected trend might overshoot the actual reality. 4. Market edge. This theorem validates bottom-up modeling. If fundamentals are strictly additive, meaning uncorrelated alpha sources without cannibalization, you can value the asset by summing the limits of its components. It is the mathematical justification for sum of the parts valuation in strictly growth-oriented environments.